Right. Notes that you get set up. It's pretty short today. Solving one-step equations. Chapter 7 lesson and all right. Oops. All right. So how do we solve one-step equations? Let's see what my notes say. So I don't upset the boss. So our goal is to get x by itself. We want to know what value for x makes this statement true. And before, or today, we gave you like 3 options over here, and you just had to plug them in and check. But that's not always going to be the case. You usually have to figure this out on your own. So it gets into some like fundamental concepts of algebra, like whatever can be done can be undone. So if we say x minus 5, and I don't want this minus 5 on the same side, so I can do the opposite of that. I'm actually going to say, I'm going to add 5 to this side. It's going to do the opposite. Whoops, I spelled that wrong. Of subtraction. Okay. So if I do negative 5 plus 5, this actually cancels out. 0. So we're left with x on the left-hand side. But in order for this to work, whatever I do on the left-hand side of the equation, I have to do the exact same thing on the right-hand side. Okay? That leaves us with negative 12 plus 5, which is math we can do. They're different signs, we subtract. So 12 minus 5 is 7. And then we keep the sign of the higher number, which is negative. So x equals negative 7. And then we can check that. If we substitute negative 7 back in, we have negative 7 minus 5. Does that equal negative 12? And we can add the opposite. So negative 7 plus negative 5 is indeed negative 12. Okay? There's no reason to ever get these wrong, because once you get the answer, you can just check it. Okay? Basic idea is whatever the operation is, we're going to do the opposite of it. So number 2. Oh, hello. So x plus 12 equals 15. So again, we're just going to do the opposite operation. So we have plus 12. We're going to do the opposite of addition. So the opposite of adding is to subtract. So I'm going to subtract 12 from one side. And if I do it to one side, I have to do it to the other. Okay. I can make this line better. Minus 12, minus 12. There we go. Okay. So 12 minus 12, this is going to cancel out. That's the point. This side's always going to cancel out. We're left with x on the left And then on the other side, nice and easy, 15 minus 12 is just 3. So x equals 3. And if we check it, does 3 plus 12 equal 15? Yes, it does. And you might say, Ellis, I could have done this. I did this in my head. I knew the answer at the very beginning. Why do I bother? And the answer is because we're establishing good habits. Okay? You're not too good to show your work. Nobody is. If I can show the work, you can show the work. No excuse. Wrong way. Now it's yellow. Alright, so number 3. That's like beige. Negative 8 times a equals 48. So this time we're multiplying, so we're actually going to do the opposite of multiplying. Do the opposite of multiplying. How many examples are there? There are 8. Yeah, get excited. Alright, so the opposite of multiplying is to divide. So I'm just going to divide both sides by negative 8. Because any number divided by itself is 1, and 1 times a, 1 times anything, is just itself. Excuse me. So the 8 or the negative 8's on the left hand side will cancel each other out, and we're left with a equals. Then on the other side, 48 divided by 8 is 6, and then a positive divided by a negative is negative. So a equals negative 6, and if we check that, negative 8 times negative 6, so negative times a negative is positive, 8 times 6 is 48. Okay? Alright, last one for the front half. What a surprise. So now we have a divided by something. So we're just going to do the opposite of dividing. Okay? And then this one is always weird because of the way we write it. Because everything else, like all the work goes underneath it. When we do multiplication, it actually ends up going on the side. For reasons. Okay? Ask your math teacher later. So what ends up happening here is we have negative 9, and it's still divided by negative 9. My mom said, yes, what about you? My mom didn't say anything about this. I'm sure she would approve. We still have 9 divided by 9, and then this is still going to cancel out. Anything divided by itself is 1. Okay? And then on the other side, this is math we can do. 4 times negative 9 is negative 36. Okay? So it's a little bit different. Same idea. Left side cancels out. Do math on the right side. And then if we want to check it, negative 36 divided by negative 9. 36 divided by 9 is 4. Negative divided by negative is positive. Okay. Mom doesn't know. You should tell Mom to subscribe so she can learn all about equations. Alright, number 5. This is the same idea except now the variable's on the right hand side, but that's okay. So we still want to get c by itself, so we need to get rid of this minus 9. So to get rid of a subtraction, we do the opposite. How much did I miss? Kind of a lot. I think I turned on the part where you can rewind though. So you should be able to go back. Get caught up. Alright, so we want to get rid of -9. So we add 9. If we do it to one side, we do it to the other. Okay. -9 plus 9. That's still going to cancel out. We have C on the right side. And then -12 plus 9. So different signs we subtract. So 12 minus 9 is 3. We keep the sign of the higher number. -3. Okay. And then if we want to rewrite it, we can say that's the same as saying C equals -3. And then it goes from being a sad face to a happy face. Might make you feel better. Oh. Can't undo. Alright, number 8. We have one word problem. Okay. John rode his bike 60 miles in 4 hours. Write an equation to solve for how fast John rode his bike. So the easiest way to do this, and the way Miss Geyer wrote it down, just to say 60 divided by 4 equals R. Right? And then that'll give us our answer. 60 divided by 4 is 15, so we can say the rate is 15, and that's 15 miles per hour. That's sort of 8th grade. We still do this in 8th grade. We do this in every grade after 7th. Anyways, so another way we could write this equation so that it looks like the other equations we've done today is we can say he went 60 miles, so something equals 60, and it's going to be 4 times whatever that rate is. We can say 4R equals 60, and then we can do the opposite of multiplying, which is to divide, and we end up with the same math. We end up with the same answer. There are two different ways you could write that equation. Both will give you the same thing. Okay. Alright, the last two. These are the tricky ones. Or as tricky as they're going to get for right now. We have 2/3 x equals 12. We're still multiplying here, so do the opposite of multiplication. And Eric should be able to get this one for the 7th graders because he's done this before. Let's see if he can. So the opposite of multiplying is to divide. So we're actually going to divide both sides by 2/3. Okay. So on the left-hand side, this is the easy part. 2/3 divided by 2/3. All that cancels out. Okay. And on the right-hand side, we have our old friend, say, complex fraction. So what we're going to do, because we don't actually want to deal with that, we're going to rewrite this as a division problem. So we have 12. Where do I want to do this? Let's do it offside. We have 12 divided by 2/3. Okay. And then we don't divide fractions. We always multiply by the reciprocal. I'm going to rewrite it again. Okay. Let me move this one so I have room to work. Excuse me. We have 12, or 12 over 1, times, and then we flip the second fraction over, it's 3 over 2. And then we multiply this out. So multiply straight across. 12 times 3 is 36. 1 times 2 is 2. And 36 divided by 2 is 18. So 12 divided by 2/3 works out to 18. X equals 18. And 2/3 of 18 is 12. Okay, like I said, hard as this going to get. So if you're multiplying by a fraction, right, quick version is you're always going to end up multiplying by the reciprocal of that fraction. Okay? So once you get the hang of it, this shortens a little bit because it'll be the same steps every time. So like if we look at example 8, last example. Oof, this is even worse, got 2 fractions. Okay. So we're still multiplying by something. So we do the opposite of multiplication. So we're going to divide both sides by 3/5. Okay. Everything on the left-hand side is going to cancel out. And then on the right-hand side, we have to work out what is 6/15 divided by 3/5. And then we rewrite it as a multiplication problem. The first number stays the same. Division flips to multiplication. We flipped our second fraction. Am I at my house? Yes. And then we multiply straight across. So 6 times 5 is 30. 15 times 3 is 45. And then we just simplify this, so I can divide top and bottom by 15. 2 over, that's the same answer. No, it's not the same answer. The same fraction as before. So in this case, x, our final answer is 2/3. And then we can check that. This one's really worth checking because we did a lot of work and we can make sure this is right. So if we say what is 3/5 times 2/3, and that works out just right. 3 times 2 is 6. 5 times 3 is 15, which is what it's supposed to be. So since it checks out, we know our answer has to be correct, and we can be done. And then our summary, we can say to solve one-step equations always something, and then you fill in the something. Alright, and that's it. That took a little bit longer than usual, 18 minutes, but got a lot of good practice in. Any questions? If not, we're all done here. What's a summary? Summary is what you put at the end to go over everything that you took notes about. And then don't forget you should have questions off to the side. Say, how do we solve equations with subtraction? And here's an example. Or how do we solve an equation where you multiply? For our example 3. Okay. Your question should be answered by the notes you took, and the summary should be a short version of everything that we did. Oh, I can rewind too. You were joking. I have too many kids that don't write summaries. That's not funny. It makes me sad every time someone actually asks, oh, we were supposed to do that. How did I know? But I know McKenna's too good for that. I was very confused. Why you were asking? I believed in you. What if we did some practice one? Get the crowd to answer. What if we say x plus 15 is 23? See if anyone's watching live, or if everyone's behind. 17 people watching right now. Good crowd. Good crowd. Nobody's here. Everyone's still taking notes. All we should do is nap. I have time for naps. We have work. Alright. I'm gonna go take a break. Have a good evening.